All right, everyone. Thanks a lot for joining us today. There's still a few people hopping on, so we are going to record this and post it to YouTube after. My name is Chris Fregley. I'm a developer advocate for AI and machine learning for AWS. Joining me today is my co-host for this whole series. Her name is Antje Barth. She's operating out of Dusseldorf.
I am. Hi, everyone.
And then also we have Ahmad Khan, who works at Snowflake. Yeah, Ahmad, do you want to say hi?
Hi, everybody. Again, my name is Ahmad Khan. I lead our AI ML strategy here at Snowflake. Been with Snowflake for now 2.5 years. And before that, I spent about close to 5 years at AWS, based out of San Francisco, where I focused on the AWS stack machine learning services. So very happy and excited to be here to talk to you about our Snowflake's current capabilities and how we integrate with the AWS stack of machine learning services.
Yeah, so we were super happy to connect with Ahmed. Snowflake is a technology, a product that I keep hearing about, I keep bumping into for the last, I don't know, like probably 7 years, or yeah, maybe 5 years, and like dating back to my time with like Databricks. So very curious to hear what they're up to these days. So to start, actually, there's a new open source project that was just launched, I believe about a month ago. And Antje had just recently covered this at a big conference I think last week, Wednesday, Thursday, called Open at Amazon. And so Antje's going to do just a quick 10-minute version of that 20 or 30-minute talk. I can track down the full version. Super popular talk. I think we had close to 50,000 people on there at some point. And I was moderating and got a lot of great questions. So yeah, Antje, do you want to start and take it to about, let's see, 9:15, so about 10 minutes if you can. Thanks.
Yes, so let me take over screen share and show you what this project is all about. All right, so let me zoom in so everyone can read. So I'm super excited to just give a quick preview of AWS Orbit Workbench. Orbit Workbench is an open source framework delivered by the AWS Professional Services team. And as Chris mentioned, it has been open sourced and shared a few weeks ago. Its home base is on GitHub, and we're going to post here the links in just a second. So if you're familiar with the AWS Labs GitHub repo, this is also where you find the Orbit Workbench project here. And I want to give you just a really brief overview of what Orbit is about and how you can leverage it, and then also give you a quick demo here, all in 10 minutes. So Orbit Workbench is trying to give you a single unified view and bring together the AWS analytics services, also machine learning services, and offer you a very customizable ML platform to also extend it with plugins of any of your favorite open source projects, etc. It's all built on Kubernetes. So this is exciting for all of you who are familiar in managing Kubernetes environments. And especially if you're thinking of building an ML platform in-house, have a look at this open source project. I'll give you a quick overview here if I click on this project website of the architecture. It's built on Kubernetes. That means it comes with all the goodness. You can define your node pools, whether you need CPU resources, GPU resources, powering this ML platform. And one of the nice integrations which comes on top is integrations into those ML services and data services in AWS. The start, if you're actually going to Orbit once you've installed it, is a front end, which is built with an Amplify application, and you're able to authenticate. So it integrates, for example, with the Cognito service to authenticate and authorize your users. And it also supports identity providers, for example, Okta. And once you're authenticated, you're able to create and use team spaces. The Orbit team spaces are secured team environments that you can set up depending on teams, on projects, anything you kind of want to carve out. And within a team space, you have access to, for example, Athena services, to query the data. You can start SageMaker ML projects. You can install your own plugins. So you can, for example, use projects like Voila or Ray in conjunction with Orbit. And it's really cool because it gives you this secured team environment, also with your own storage services. So it sets up integrations with an S3 bucket for the team, with an EFS file share, etc. And I'm going to show you how this looks because that's more impressive. So I'm jumping here in a demo installation of the Orbit Workbench that I have. And you can see here, this is the front end I've talked about. And I'm running this on a Kubernetes cluster that is installed when I install the Orbit Workbench environment. And here you can see I've created two teams. One is called the Lake Creator, which is kind of an administrative team. And one is called the Lake User, which is just a common user team that would leverage that environment. All right, and if you jump in there, you're presented with a Jupyter Hub environment, so you can start up your services. And I've just created here two Jupyter server environments for the teams. So let me show you the first one. This is here, I'm logged in as the Lake Creator. This is an administrative interface. And what I've done in preparation, I've set up a data lake environment. And you can see here a couple of integrations in this Jupyter Lab-based environment. You have the usual ones, Git integrations that come with Jupyter Lab, but also here the Orbit environment. So the security policies, the roles I'm using, you can see here as the admin team, I do have sudo access, and I've also access to my Kubernetes environment as an administrator. You can define the team profiles, which give you access to specific resources. And you also have integrations. For example, here's an integration with the data catalog service on AWS using AWS Glue. And those are a couple of the databases and tables that are in here. So I can click here and get a quick preview of the data. This is just some sample data I've ingested in this data lake environment in my S3 buckets. So you can have a quick preview of those tables and the data sets you're loading. You can run jobs on this Kubernetes cluster, which I'm going to show you in a second. You can also, and listen, if you're a machine learning practitioner, and if you want to schedule notebooks to run, you can schedule them as cron jobs. So this is really exciting. You can also, through an integration and a plugin with Redshift, you can spin up what the team calls transient Redshift clusters, which means as a data scientist or ML engineer or data engineer, you can, through the notebook, initiate a Redshift cluster, which comes up with access to your data through these S3 buckets, for example, already set up with the access controls. And only your team can then use the Redshift cluster, query, run analytical queries. And you can also tear it down again all through the notebook environment. So pretty cool. And as I said, it comes with storage integrations. So you can use EFS storage that comes up. You can deploy EBS, local storage if you need for your notebook environments, etc. All right, so let me switch over to the user. So I'm now in another team space, which are authenticated in. So you can see here, team name is Lake User. And this one here has also the capability, for example, to run background jobs on the cluster using Fargate, which is the serverless way of running containers. And the nice thing here is this demo environment comes already with a couple of sample notebooks. And let me just briefly show you here a few of them. And they're all available through the GitHub repo if you want to have a look at it later. So the Lake Creator, the notebooks here set up the environment, populate also with data sets, so you can play around with it. And in the data analyst, so assume you're in the role of a data analyst, There's a couple of notebooks that show you the integrations. For example, one with Amazon Athena, which is an interactive query service built on Presto to query data that is sitting in your S3 environment. So what you can do here is basically you're importing the Orbit SDK, and then any specific functions that abstract how you can interact with the services. So for example, with Athena. And the nice thing is that you now have access to a lot of really cool Jupyter magics that the team built. So this is just the environment dump here. I'll show you one here. There's Jupyter magics that come with the Orbit implementation that you can use, for example, to connect to Amazon Athena by just providing here the Jupyter magic and then a reference to your database in the data catalog. And I've put in here a link that shows you the code. So again, this is all open source, so you can have a look for yourself later. And here's, for example, this Jupyter magic that's helping you to connect and later also query Athena and work with your data sets. So really, really cool. And you can query the catalog here and work with the data, write SQL queries, and everything really from your notebook environment. There's also a notebook that shows you how to work with Redshift, backed by the capability called Redshift Spectrum, which allows you to query, again, data sitting in S3. And here, for example, you can check for any Redshift clusters. And if you're calling this connect to Redshift magic again, and this is really abstracting a lot of the different calls you would have to do to connect to Redshift otherwise, you just provide a cluster name and starting it and say you want to run it with 3 nodes. And if this hasn't been set up yet, this will also spin up this Redshift cluster for you, which you inside this team space can then use to run queries and work with your data. So really, really cool. One notebook I want to show you here, and let's actually run this live, is how you can schedule notebooks. So let me do a kernel restart and run all cells. And let's pray to the demo gods here, as I'm doing this as a live demo. And I'm opening up here the cron jobs. And here we go. So again, I'm using the Orbit SDK. And what I can do now is using a magic run notebook to execute the notebook that I'm specifying in here as a job on the Kubernetes cluster. And it's using a project called Papermill to schedule those notebooks. And you can run it ad hoc, what I'm doing here. Or you can also use a magic called schedule notebook and then provide here the regex expression for the cron job. And this will also run a notebook that you specify. And you can see here 2 jobs are running. This is the cron job, and it's using the Fargate service to execute this job. So really cool, really easy to use out of the notebook environment. All right, and you can also work with the ML services. So there's also a SageMaker example notebook in here. The team is currently working in integrating the operators for SageMaker to have SageMaker even integrated as more of a first-class citizen. So from the Kubernetes environment, you could also start then the Amazon SageMaker jobs if you like. Or in this sample notebook, you can also do this by calling the APIs from this environment. So a lot of cool stuff. And if you're interested in that, check it out. We'll share the links here. And yeah, hopefully this is some exciting news for you. We would be super happy to hear any feedback if you like it and what you would like to see as well being added. All right, and with that, let me stop my screen share and hand it over to Ahmad, who will now give you a nice overview of Snowflake.
Thank you. Thank you. That was an awesome demo. Looks like a very exciting open source project. Yeah, so so let me go ahead and share my screen here, and hopefully everybody can see my screen. And so in the time that we have here, I'll take you through, give you a quick Snowflake intro. For those of you who have not really had the opportunity to play with Snowflake, we'll look at how our customers are using Snowflake for data science, where we sort of fit in the stack for data science and machine learning, where we rely on our partners such as Amazon SageMaker. And then I'll take you through a quick Jupyter lab demo and do some time series prediction using data and Snowflake, sort of enriching data from our marketplace, and then showing you how easy it is to grab third-party data sets. I don't think we'll have time today, but maybe if we have 5 minutes at the end, we'll look at our newest capability, which is Snowpark and Java UDFs, and we can talk about how that enables functional data engineering and also model scoring within Snowflake as well. And so let's really dive into it. For those of you who have not, you don't know about Snowflake, we started out in 2012, and we were in stealth mode for about 3 years. We built a cloud data warehouse that was custom built from scratch for the cloud. And so initially, we launched our services on AWS. We came out of stealth in 2015. And since then, it's been an amazing ride. It's been an explosive growth. And so we are essentially a SQL-based, we started out as a SQL-based distributed SQL engine running a data warehouse OLAP workload on top of AWS. And really the key difference between Snowflake and some of the other offerings in that space at that time was the fact that we came out with a new architecture which separated storage from compute. And so now with this new architecture, you had a centralized storage system that was based on Cloud Object Store. So initially it was built on top of S3 in AWS, and then we expanded our services to Azure first, and now we're also available in GCP. But essentially a centralized storage system that relies on the backend on S3, and then on top of that, you can launch various clusters and of different sizes and be able to run those clusters for different workloads independently of each other. And so the benefit of this is that you're isolating scaling storage from compute and also from compute isolating different compute clusters from each other as well. So you could have a large size cluster running machine learning, you could have another running BI, maybe another running BI for just marketing, another running dashboards for executives and whatnot, and they're going to be operating independently. So you really don't run into scaling and concurrency issues. And that's really enabled by our third layer, which is the general services layer that provides the security, the transactional support. Snowflake is a fully transactional asset compliant database, custom built for the cloud and written from scratch. One of the key things about Snowflake right from the beginning was the file system. And because we are on a shared storage, on an independent storage, and we wrote the file system from scratch, it enables a very unique capability, which is live data sharing. And so with live data sharing, any Snowflake customer can share data with any other Snowflake customer in a way that there is no data copying or movement of data. And so this is a very powerful concept, because now our customers, we're sort of building this data cloud, a network of data providers and consumers, where the data providers just say, hey, I want these rows and these columns within my data to be available to this other Snowflake customer. And this is live. And so as the data provider updates their data set, it's available to the data consumer in real time. And so a lot of our customers are leveraging this for large scale data sharing rather than using file sharing over FTP or using APIs. And so this is replacing APIs and file sharing for a lot of our customers. And we've built a public data marketplace on top of this, and combine this with the ability to move data between different geographic regions within a cloud or across cloud. This really is the foundation for what we are calling data cloud, where you can have data sets that are available in different geographic regions, and you could be consuming data from companies that provide you third-party data sets, or from to and from partners of your businesses, where you can consume data very easily through Snowflake without using file sharing or APIs. So that's sort of Snowflake in a nutshell in 5 minutes. But let me switch over and talk about sort of machine learning and what we are seeing. And so in the analytics space, which is our core competency, we're seeing this shift from the traditional analyst BI role, asking questions about the past, what happened, why did it happen in the past, and to now more prescriptive analytics, data science, and machine learning, and asking questions like, what will happen? What can I do to have a certain outcome? What can I do to avoid a certain outcome? And really, if you think about machine learning, it's way bigger than just predictive analytics, right? Predictive analytics is sort of saying, hey, I want to predict or forecast my sales or usage of my service. But machine learning is absolutely bigger than that. It's if you look at stuff around deep learning on unstructured data such as images and audio and video analysis, there's object detection, voice recognition, there's facial recognition, sentiment analysis. So it's way bigger than just time series data. However, what's happening is, what we're seeing is that as that technology is sort of trickling in to our customer base in the enterprise space, from the large tech companies that have very successfully deployed this, the large enterprises and the businesses out there are struggling with this. And fundamentally, the reason why is because the machine learning workflow is very different than your traditional software development lifecycle. And so specifically, if we talk about challenges, what we see here is 3 major challenges, right? It's first and foremost, there's a huge dependency on data with machine learning. So it's hard to get all the data into one place, and it's even harder to secure and govern it. Giving appropriate access to the right people in a timely fashion is a hard problem. And I believe the bigger one is this central one, which is, it's hard to put models into production. So what we see is a lot of isolated experimentation by data scientists and perhaps a notebook environment. And when it comes time to put that experiment into production, it's hard to do. You need production grade pipelines. There might be a lot of data transformation just happening in the notebook with an isolated data set, and now you have to put that into production, keeping in mind that not only are you going to train but retrain that model every week, maybe every day, and then the same features that you're going to use to train a model need to be available not only during training but also during inference time as well. And the other last one that we see is a lot of times customers will spend years building a single source of truth, where they put all their data, they're doing all their analytics and reporting. But for data science, what ends up happening is you take snapshots of data out of that single source of truth, duplicate that out somewhere else, and then use that for machine learning. And what that happens is that you're not only duplicating your data sets, but you're also losing governance on it. And then a lot of times those insights that are produced by the machine learning algorithms don't make it back into your analytics platform and are not usable by the entirety of your organization, including your SQL analysts. And so I'm just also monitoring the questions here, and I'll take pauses and answer them as they come along. So question, is this GDPR compliant? Yes, so we absolutely have a lot of security certifications. This is in AWS. This is a technology that's built on top of S3. So we have GDPR. Customers are running CCPA compliant workloads on it. Everything in Snowflake, security is the foundation of what we do, because we're protecting our customers' data. So everything is encrypted in motion and at rest. And so it's absolutely GDPR compliant. There are additional features within Snowflake that will let you implement and adhere to GDPR rules as well, where you can actually go back in time and report on data as of a certain date. And you can also set policies of when you want to delete certain information as well. So all of that is absolutely possible. And so what we see, and continuing on the problem statement, is with the data science and machine learning sort of workflow. As you're collecting, visualizing, preparing data, then you build and then you deploy models, is very consistently for data engineering and data science teams, that they're spending more than half of their time doing data prep, collection of data, doing feature engineering, feature creation, data wrangling. And that takes the bulk of the time for the data scientists. And that's where Snowflake really plays, right? And if we look at a very high level, Snowflake gives you one place to sort of store all your data and govern it. And so it provides not only the role-based access controls, but advanced security governance features such as dynamic data masking, row level, column level security, automatic tagging of PII, differential privacy via k-anonymization, is all sort of built into the Snowflake platform. And then secondly, we provide integrated, scalable, and very, very fast pipelines. And so you can implement pipelines in SQL, where you have CDC data available, so change data capture, you can take actions on it, define multi-stage pipelines, do feature pipelines using SQL. And now we're making that ability to define multi-stage complicated data pipelines in Java, Scala, and then very soon in Python as well. And really the number one reason for that some of our largest customers are running data science on top of Snowflake is the fact that we are providing those advanced governance features, make sure that only the people that need to see certain sensitive data can see that data and nobody else. And it's super easy to define those policies across all data in your organization. So in terms of sort of a holistic product strategy, we want Snowflake is not a machine learning platform. So we rely on the best of breed platforms, and the number one partner there for us is actually Amazon SageMaker. Most of our customers are in AWS. And so by default for them, anybody who's doing custom coding of algorithms has a data science team, will be looking at or using Amazon SageMaker. So it's one of our top machine learning partners. So we're not a machine learning platform. We are a data platform that provides the ability to aggregate data, clean up data, do feature engineering, pipelining, and do it in a governed manner. And so we work with a machine learning partner. And I'll talk about in the next slide where we play and where we rely on our machine learning partners. So our strategy is that we want Snowflake to be the best place to put for our customers to put all their data, no matter what machine learning tooling, library, language, machine learning platform you end up using. So there's connectivity. There is basic connectivity, optimized connectivity from Python. So we have a Python connector with integrated Panda support. We have a Spark connector with pushdown capability. We have an R connector as well, but that's just basic connectivity. You can connect from any machine learning tool, any, like even Jupyter lab running on your own local desktop to large scale data in Snowflake. The logos that you see here are where we have product level integration. So for example, with Amazon SageMaker, we just released our first integration with AWS Data Wrangler, where Snowflake can act as a data source for Data Wrangler. There's another one coming for Amazon SageMaker Autopilot, where you'll be able to not only train a model, but also do predictions right from Snowflake SQL interface. So just using SQL to train models as well as to do predictions. And in the back end, it'll be using Amazon SageMaker Autopilot services. And so similarly with some of these other machine learning partners as well, Snowflake is an investor in some of the leading auto ML tools, such as Data Robot and Data IQ. And so there's a bunch of product level integrations there as well. We've been sort of so let's focus our attention on data, and then talk about languages, and then we'll talk about where Snowflake play in the machine learning workflow. And so we're sort of the de facto place for our customers to put in structured and semi-structured data. So if you have CSV data that you're bringing in, if you have JSON data, you can just throw into Snowflake. And historically, we have not supported unstructured data. And so as we support our customers that are running large-scale machine learning workloads, they needed support for unstructured data, and that's what we have enabled now. So we're in preview with unstructured data support as well. So you can throw in images, audio, video files into Snowflake as well. Now this is very key. This is just your first party data. We believe that your competitive differentiation for your organization is going to be in the data that you have. Pretty much every organization will have access to the same sort of machine learning, deep learning libraries and algorithms and platforms. Really the key differentiation is your data, and that differentiation becomes exponential when you bring in your partner data and you bring in third-party data sets. And that's the big vision with the data cloud, is that if you are a Snowflake customer, you get easy access to third-party high-quality data sets by companies whose whole business it is to sell data. And so these are very high-quality data sets such as weather data sets, finance data sets, demographic data. We even had COVID data in the last year. A lot of our companies, retail customers, have been using COVID data from our marketplace, creating new features, joining with their first-party data sets, creating new features, and instantly enhancing the performance of their models. So we talked about the data, we talked about our partner integrations. Let's talk about what languages are supported in Snowflake. And so primarily we've been a distributed SQL engine. And one of the reasons for our success has been, it's so simple to use. Anybody who can write SQL can use Snowflake. And about 3 years ago, it started out as a SQL engine. And about 3 years ago, we introduced the ability to do large scale transformations and pipelines in SQL. A lot of our customers adopted that, they loved it, but a lot of them said, hey, for my data science workloads, I'm doing all of that business logic using data frames, using languages such as Java and Scala and Python. They were using PySpark, EMR, or other managed Spark offerings such as Databricks. And they came to us and said, hey, you're telling me I can do this faster and cheaper in Snowflake. but now you're asking me to convert everything that I have in Java, Scala, and Python to SQL. And so they never migrated. And so that's why we've listened to a lot of our customers, and we're enabling Java and Scala natively in Snowflake, and then Python becomes available by the end of the year. Java and Scala available today in preview, and then Python becomes available. And the API interfaces are very similar to PySpark and Spark Scala, and intentionally so, because we want our customers to be able to very easily port that that workload into Snowflake. Okay, so we have a few questions. So regarding reports, can you use EMR Spark to process data and SageMaker to read and write to Snowflake without transfer the data on the internet? Yes. You can launch an EMR cluster in the same region as your Snowflake account. So the Snowflake account is going to be in one AWS region. And if you launch an EMR cluster in the same region, your traffic between the EMR cluster, first of all, the way you connect your EMR Spark is going to be with Snowflake Spark connector. You can actually push down a lot of processing, data frame processing, even Spark SQL processing down into Snowflake using our connector. The way the traffic is handled is because they're going to be in the same region, it's not going to traverse the internet. Now, if you want to be absolutely, lock it down, you want to be able to lock down the traffic and prove that for regulatory reasons. We also support a AWS private link, so where the Snowflake managed VPC can get connected to your VPC through a private link connection, and then you can go. Your traffic will take that private link. Another one, are there case studies of using Snowflake in the financial services industry to use ML to make price prediction based on structured and unstructured data? So we do have a lot, Rain, we do have a lot of customers in the finance industry that are using data. I'd have to look up if we have specific case studies around that. So I know in the insurance industry, we have Pacific Life. We have one of the largest brokerage services that is standardized on Snowflake plus Amazon SageMaker to do a lot of their machine learning. But specifically a case study on structured and unstructured data, I would have to see and share that offline. All right, so let's move on and talk about where Snowflake plays and where we rely on our partners. And so this is a super simplified machine learning sort of workflow. You're doing data prep and feature engineering. That's where you're spending the bulk of the time. Actually, in fact, like I said, for most of our customers is at least half or even more than half of their time. And thus, that's why this rectangle is so big. Then you're training the model, you're deploying the model, and then you're monitoring and managing the model over time. And so anywhere where you see blue here is where Snowflake will have native capabilities. And any of the orange boxes are where we rely on machine learning partners to enable this workload. And so at the foundation of this is a scalable storage. That's actually in AWS built on top of S3. And so think of Snowflake as a large-scale OLAP analytical database that's fully ACID compliant and can provide transaction support, multi-statement transaction support that's built on top of S3. And we provide the storage at the same price point as S3, so $23 per terabyte per month. We provide the optimized connectivity for your tools, but the number one reason why some of the largest Snowflake customers are running data science on top of Snowflake is the built-in security and governance. So it's SQL-based, role-based access control. who gets to see what data. You can absolutely lock it down, and by default it is locked down. But advanced security features such as row level, column level security, dynamic data masking, tokenization, differential privacy, automatic tagging of PII data. So all of that is sort of built into the platform. For data prep and feature engineering, a lot of our media streaming customers, retail customers will bring in, and that's as an example, will bring in weather data. That's what they will get started with. They will add new features, instantly get a boost in the performance of their models. You can bring in demographics data, finance data from our marketplace, or through one-on-one data sharing with your partners. So you can do data enrichment here. Large scale raw data sets, let's say you have transactions data, and from that you're doing feature calculations such as how many items has this customer bought in the last 30 days? How many times have they accessed our system or our website? All of that is very easily calculated using our ANSI SQL views. But if you want to automate that, do training and retraining every day, every week, is where you would make available sort of end-to-end pipelines. And you can do that with streams and tasks in Snowflake, but you have to implement that using SQL. And so that's where a lot of our customers said that, hey, we have that business logic already implemented in Java, Scala, and Python, and we love working with data frames. And that's why we've introduced Snowpark and UDFs, because that capability enables you to create multi-stage complicated pipelines in Java and Scala today, and very soon in Python as well. Once you're taking very, very large raw data sets in the data prep and feature engineering space, and you're aggregating, you're cleaning up the data, and so the data set or sampling the data, and data set becomes a little bit smaller, but also wider, right? Because you're adding the features and that you're creating as separate columns. And so you're going from a very long data set to maybe a smaller, wider data set. And you do that, all of that in Snowflake using pipelines. And once you have it, have it available and ready for training, is where you would use a partner technology to run the training operation. We do not support training natively in Snowflake. And so you would have to pull the data into the memory of the compute service that you're using. And so I would just stick to Amazon SageMaker in this presentation. It's our #1 partner by far. And so you can launch notebooks, you can launch training services. In SageMaker, you can do custom Docker images for your training jobs. And if you build custom Docker images, very easy to include Snowflake's Python connector. So you can very efficiently pull data directly from Snowflake into a Pandas data frame. And it's highly optimized because we will use the Apache Arrow format to transfer the data in a binary format. You can run the training in Amazon SageMaker, and which produces a model artifact. The model artifact can be deployed in a couple of patterns. Within our customer set, it's usually you deploy the model as a real-time API endpoint, where you have maybe requirements of sending single rows for inference, right? And you want those the inference and the prediction to be done in sort of near real time, double-digit milliseconds. And so you can deploy that as an API, but you do that outside of Snowflake. So this is where you would use something like Amazon SageMaker endpoints. So you will use the endpoints in SageMaker to deploy the model, but you can connect to it using a Snowflake user-defined function called external functions. Now, external functions are user-defined functions in Snowflake that map to an external API. And so there is, a few lines of code that you have to write to make this integration happen. But once you do, you can throw features in Snowflake that are stored or calculated in Snowflake to that API endpoint, get predictions back, and then save those back into Snowflake. Build dashboards on top of it, or run data applications from there. And so by just doing this, what you will enable, a lot of our customers will enable all their SQL analysts to use these models that are deployed outside of Snowflake. And so they can write a simple SQL statement and call this predict function, and they'll be able to use the model just using Snowflake SQL. So that's one pattern of a real-time. The other bigger pattern is doing bulk ML prediction. And so this is where, if I have maybe 100 million rows and I want to run inference against those 100 million rows, and as part of a pipeline or a batch process. And so this is where you can actually bring a trained model, import that into Snowflake, and run and execute that in Snowflake as a UDF. So with the introduction of Java, Scala, and Python UDFs, we now have the capability to run bulk ML inference as part of a pipeline in Snowflake. And so that's a very nice use case and scales really well with Snowflake, because inference is an embarrassingly parallel problem. So as you increase the size of our clusters, which we call warehouses, you can literally, as you go from a small to a medium to a large, you're doubling the size of the cluster. And in theory, you can actually decrease or half, cut the time for the inference operation in half as you scale bigger and bigger. And the beauty of Snowflake is that it's instantly scalable. A warehouse becomes available in a matter of seconds, and it goes back to sleep in a matter of seconds. And we bill per second as well. And so if you have a large size cluster that's taking 30 minutes to do the inference, if you go and instantly switch up to an extra large, which is the double size of the large, you can cut the time of execution to up to 15 minutes, still pay the same amount, because you're paying by the second. Okay. And then finally, the monitor and management of models. We don't have product capabilities within Snowflake. So here you would use something like Amazon SageMaker to do versioning of models, to do model lineage, and even to do like other advanced capabilities such as explainability of models. But a lot of these partners actually can persist data back into Snowflake, persist data about experimentation, runs, or metadata about the model performance, hyperparameters, all of that data. A lot of our customers will persist that back into Snowflake and then create dashboards on top of it. But this is an area where we rely on our partners for model management and monitoring and drift detection and whatnot. Okay, so we have another question around, can you talk more about live data pipeline capabilities? As SQL pipelines sound like batch process and not quite real time, so data set cannot be that large. Sounds like one can use the API and use a predict function to have more real-time analysis. And so it really, Ray, that's a great question. I'll be very transparent here. It really, so we can handle, we have customers that have petabytes of data in Snowflake, so it scales really well. However, it is not an OLTP database. It's not something that's meant for large scale individual writes and large scale individual reads as well. And so if you're using an OLTP database such as MySQL, Postgres, our RDS, any of the RDS databases, those are OLTP databases, not really meant, and Snowflake doesn't play in that space. So our sweet spot is large scale analytical queries on large amounts of data. However, having said that, the pipeline capability, it really depends on what you mean by real time. If you mean for real time, as new data is being ingested and you want the the insights to become available within under a second or in few hundred milliseconds, then Snowflake is not going to be the right solution. For the pipelines capability, we like to call it near real time. And so as new data is coming in, there's going to be a delay of about a minute or so for this pipeline capability. And so the way to think about this is any kind of analytics engine will batch up the operations. And so we will do micro batching in the background. We do have a connector for Kafka, where you can connect a Kafka stream directly to Snowflake. However, there's going to be a lag of about a minute. And for some customers, that is good enough for large amounts of data. All right, so I know we're coming up on time, so let's quickly jump over to the demo. And so here, what I'm going to be doing is time series prediction. So I have using the city bike trip data that's openly available in New York City city bike service. And what I'm going to be doing is doing trying to predict the usage of the service in aggregate first, and then we're going to do it for a specific, one of the busiest stations in our service as well. The machine learning library that I'll be using is Facebook Prophet. I'm running this on my local machine, and I'm connecting to data in Snowflake, right? In any kind of Python environment, very easy to connect to data in Snowflake. It's a single pip install of our Python connector. And if you're going to be using the pandas library, you want the pandas version of that. So let me bring in my credentials, import the Snowflake Python connector, the pandas library, and the Facebook Prophet library, right? And so here, what I'm doing is connecting back to Snowflake. I'm giving the credentials, the warehouse that I'll be using. In this example, I have the last 8 years worth of data at the hourly level. And so there's 113 million rows in this view. And if I were to bring all the raw data into Snowflake, I would probably, crash my notebook server here. So what I'm doing is aggregating to the daily level and using this fetch pandas all to very efficiently bring that data into pandas data frame. And from there on, my experience as a data scientist doesn't change, but I can go ahead and train my model. I can then make predictions on it. I can plot the predictions. So my experience as a data scientist doesn't change much. And so as it goes through and runs the predictions, what I'm doing here is I've trained the model. I am saying, hey, go ahead and make the predictions for the next 2 years, and then go ahead and plot this. And so here, you can see the black dots are the actual trips taken for the entire city bike rental service in New York City, and the dark blue line is the predictions that are made by the Facebook Prophet model. And you can see in aggregate, it's making the predictions, projecting it over the next 2 years. But the business problem here is that I want to find out my busiest station and make predictions for that busiest station. So I can run a very simple query, super easy to do. I find out that Pershing Square North is my busiest station. So let's make predictions for that, and let's go and evaluate that. I'll bring in the data for Pershing Square North. Very easy to do, again, with a simple SQL statement. And then what I can do is I want to take into account my holidays for the US, and then I'll train the model and then evaluate. And one of the metrics that I can use is the root mean squared error to see how accurate my model is. And so here you can see it's 355. So as a data scientist, it's my job to bring down that root mean squared error, right? And so for that, I need access. So I have an intuition as a data scientist here, and the intuition is that on rainy days, fewer people are gonna ride bikes, and for that I need a rain or a weather feature. And so if I was working outside of Snowflake, I would have to grab that data from an API, scrap that, and then worry about keeping that updated if I want to implement that as an automated pipeline. In Snowflake, what I can do is get out of my SQL editor and go look at the data that I have at my disposal. And so if I switch over to data, I will see my first party data. And then I will see data from any of my partners that are doing one-on-one sharing with me. But in this case, I want access to a high quality weather data set. So I can go to the marketplace, and in the marketplace, there's hundreds of data sets from high quality data providers. And so here I'll go to the weather data. And I have, you can see multiple providers of data. And so here, what I can do is I'm going to use this weather source data, which is provided for free because it's limited. But I can just go ahead and rather than consuming an API, all I have to do is just click this get data button and say, okay, give access to the DBAs as well as the data scientists, accept the T's and C's, hit create database, and done. Boom, I have this weather data and their forecasts available in my Snowflake account. And so as I come back and I look at it, I found that there's a total precipitation in inches column that I can use. I'll do some preliminary data scaling or feature engineering in Snowflake, join that weather data with my first party trips data to come up with a new rain feature. So not only does it have the number of trips taken for every day, I have an indication to my model that, hey, how much wetness or how much rain there was that day. And so I'll add that rain feature as a regressor to my model, and then go ahead and retrain and reevaluate the model, right? And so, here, after adding the rain feature, very quickly bringing in the weather data and adding one rain feature, you can see that I was able to reduce the root mean squared error to 207. Still a pretty crappy model, but there's a significant improvement in how accurate the model is. And really making 2 points here. Number one, super easy to bring in, and enrich data with high quality data sets. And number two, a lot of data scientists will focus on their algorithms and hyperparameters, but really the differentiation is in the data and the features and the quality of data that you bring in that really makes a difference in terms of model performance. I know there's this is a demo that I can go on for a while. I know we're up on time, so I will stop here, and hopefully this was a good one. You learned something, and I'm happy to answer any questions. So Anta and Chris, do we have some time to take questions, or are we over time?
Yes. No, we can definitely go through a couple of rounds of questions here. So first of all, thanks so much. A great presentation and great demo, Ahmad. We had a lot of questions coming in. You already answered, I think, a good amount of them. So to everyone here in the call, if you have any more questions, feel free to post them. The last one coming in here, the demo notebook you showed, is this shared somewhere in a public GitHub repo?
This one is not in a public GitHub repo, but I would encourage you. There are a bunch of them, including some very cool recommendation engine one on guides or quickstarts.snowflake. And you can take a look at this. This is something that I wrote late last year. Is building a recommendation engine using AWS SageMaker. So it's a guided lab that you can go through, and all the code is in this GitHub repo that's publicly available.
All right, great. And we did have some questions early on in the presentation when you mentioned security is obviously, always the biggest priority. We had a question around GDPR compliance with Snowflake. Maybe you can just elaborate briefly on that.
Yeah, I did try to address that question. So a lot of our customers are running GDPR and CCPA compliant workloads on Snowflake. So from a data encryption and basic network security, we cover all the bases. Data is encrypted in flight. It's always encrypted. There's no option to do unencrypted data storage. So data is encrypted at rest, in flight. we have some of the highest security compliance certifications available. We're SOC 2 compliance, we're FISMA compliance, FedRAMP, and now FedRAMP Plus compliant as well. And for GDPR, we have additional capabilities where our customers can go back in time and be able to do reporting on what kind of customer data they had maybe like a month ago, 2 months ago, 3 months ago. So there's a time travel feature that our customers use. And then you can take zero copy cloning or snapshots of data in Snowflake as well. So a lot of our GDPR customers will use that. And then they will use our managed replication services to make sure that the locality of data that they're adhering to. So for example, if certain data needs to reside in our European ones, they can keep it in a European location and then move some of the other data globally anywhere else. And so we provide the global data mesh as well as replication of data as a service as part of our Snowflake service.
All right, perfect. And we had one more around feature stores. So could I use Snowflake as a feature store for machine learning? And why?
Yeah, absolutely. So you can. And a lot of our customers are using us for a feature store. However, when you look at feature store and current, like there's a bunch of startups in this area, we do not cover like all of the functionality that a sort of purpose-built feature store will make available. So you can do large-scale feature creation and make it available. What we don't have is a low latency API or serving of features that you might need for a low latency prediction service, right? So that's something that so our customers will build the feature store, but then they will move the data into something like Redis or an in-memory store to make available. So they will calculate the features in Snowflake, but then they will cache those features in an in-memory store such as Redis or DynamoDB in memory or just DynamoDB, and then serve those features from that low latency store.
All right, yeah, makes sense. And I think that covers the questions. The other ones you answered already throughout your talk. Thanks for that. And yeah, so I think that's a wrap then for today. Thanks so much for joining us, Ahmad. I really appreciate the deep dive into the Snowflake solution today. And we will share the recording on YouTube, Data Science, on aws.youtube.com in a few days. Also, I just want to do a quick plug here. We do have a hands-on workshop coming up in 1 week from now. If attendees are interested in that, building an end-to-end pipeline with Barth and TensorFlow and SageMaker. And also, we do want to point out our O'Reilly book, Data Science on AWS, which also covers a lot of topics from data ingestion to model training, tuning deployments, security, etc. All right, with that, thanks so much again, and hopefully see you around for our next webinar in July. Thanks so much.
Care.
Thanks so much.
Bye-bye. Bye.